You see, space isn't the serene, peaceful void that poets write about or that we see in those beautiful NASA photographs. No, the universe is a place of unimaginable violence, cosmic nightmares, and phenomena so terrifying that they make our worst horror movies look like children's bedtime stories. Tonight, we're going to explore the most bone-chilling, sleep-stealing discoveries that astronomers have made lurking in the infinite darkness above us. If you find comfort in these explorations of the cosmic unknown, I'd be incredibly grateful if you'd consider subscribing and liking this video. It helps the algorithm find more curious souls like us who aren't afraid to peer into the abyss and ask the difficult questions about what's really out there. The visuals are here to guide you, but feel free to close your eyes, let your imagination drift, and prepare yourself for revelations that will haunt your dreams. I'd love to know where you're listening from tonight. Comment your time and location below. Picture this for a moment. You're standing in your backyard on a clear night, gazing up at what appears to be a peaceful tapestry of twinkling lights. Those distant suns seem so calm, so eternal, so beautifully arranged across the cosmic canvas. But what if I told you that at this very moment, as you stand there in your comfortable bubble of earthly safety, there are invisible predators stalking through the darkness between those stars? What if I told you that wandering through our very own galaxy are cosmic monsters so powerful they could devour our entire solar system without us even knowing they were approaching? Welcome to the terrifying reality of our universe, where beauty masks unspeakable horror and the most dangerous threats are often the ones we cannot see coming. Tonight, we'll journey through discoveries that have left even the most seasoned astronomers lying awake at night, questioning everything they thought they knew about the cosmos we call home. Let's begin with something that should make your blood run cold. Right now, as you sit there listening to my voice, there are approximately 100 million invisible destroyers wandering through our galaxy. They're called rogue black holes, and they represent perhaps the most chilling discovery in modern astronomy. These aren't the relatively well-behaved black holes that sit at the centers of galaxies, anchored in place by gravitational relationships we can predict and study. No, these are cosmic nomads, ejected from their home systems by violent galactic collisions, now drifting silently through the void, like invisible sharks in an ocean of stars. They have no light, emit no radiation, and give no warning of their approach. Just this year, scientists using the Hubble Space Telescope spotted one of these wandering nightmares lurking in our cosmic neighborhood. It's only 5,000 light years from Earth, which in cosmic terms is practically next door. This particular monster weighs 7 times as much as our Sun, compressed into a point so dense that it warps the very fabric of space and time around it. The most terrifying part? We only discovered it by accident through something called gravitational lensing. As this invisible predator drifted between us and a distant star, it bent and distorted that star's light, creating a cosmic magnifying glass effect that revealed its presence. Think about that for a moment. This thing had been silently stalking through our galactic neighborhood for who knows how long, and we only noticed it when it happened to pass directly between us and another star. If we know there's one wandering black hole so close to us, astronomers grimly note, then there are almost certainly others. The mathematics are sobering. In our galaxy alone, there may be as many as 100 million of these rogue destroyers, each one a gravitational death trap capable of shredding anything that ventures too close. But here's where the story becomes even more nightmarish. These cosmic predators don't just wander aimlessly through space. They hunt. And when they find prey, the results are nothing short of horrifying. Astronomers at UC Berkeley recently witnessed something that will haunt the dreams of anyone who truly understands what they observed. They discovered a rogue black hole positioned 2,600 light-years from its galaxy's core in the process of devouring a star. This wasn't just any ordinary cosmic event. This was the first time scientists had ever optically detected what happens when one of these wandering monsters finds a victim. The process has a name that sounds almost whimsical until you understand what it describes: spaghettification. When a star ventures too close to a black hole, the gravitational forces become so intense that they literally stretch the star into long, thin strands, like cosmic spaghetti. The star is torn apart atom by atom, its material spiraling into the black hole's accretion disk while screaming out its death throes in the form of radiation that can outshine an entire galaxy for weeks or months. But here's what makes this discovery truly terrifying. This tidal disruption event, as scientists call it, occurred far from the galaxy's center, in a region where no black hole should have been. This means there are rogue black holes lurking in the dark spaces between stars, areas we previously thought were relatively safe. The universe, it turns out, has hidden predators in places we never expected to find them. The implications are staggering. If rogue black holes are hunting in the galactic suburbs, how many more are out there that we haven't detected? How many of these invisible destroyers are silently prowling through regions of space that we assumed were empty? The answer, according to astronomers, is deeply unsettling. These cosmic predators may be everywhere, and we would only know of their presence when it's far too late to do anything about it. Now, let me tell you about another cosmic horror that makes rogue black holes look almost tame by comparison. Deep in the darkness of space, there exist objects so powerful that their magnetic fields could literally rip you apart at the atomic level from hundreds of miles away. They're called magnetars, and they represent some of the most extreme and terrifying objects in the known universe. Imagine, if you will, the remains of a star that died in one of the most violent explosions the universe can produce. When certain massive stars reach the end of their lives, they don't simply fade away quietly. Instead, they explode with such fury that they can briefly outshine entire galaxies, hurling their outer layers into space at speeds approaching 10% the speed of light. What remains after this cosmic catastrophe is something that defies human comprehension. The star's core, containing more mass than our Sun, collapses into a sphere only 12 miles across. The matter becomes so dense that a teaspoon of it would weigh as much as a mountain. But some of these stellar corpses, perhaps 1 in 10, undergo an even more terrifying transformation. They become magnetars, zombie stars with magnetic fields so powerful they warp the very structure of reality around them. To put this in perspective, Earth's magnetic field, which protects us from harmful solar radiation and guides our compasses, measures about half a Gauss. A refrigerator magnet produces a field of about 100 Gauss. The most powerful magnetic fields ever created in laboratory settings reach perhaps 45 Tesla, or 450,000 Gauss. A magnetar's magnetic field measures 100 trillion Gauss. It's a number so large that it loses all meaning until you understand what it can do. NASA has calculated that if a magnetar passed within half the distance between Earth and the Moon, it would wipe out every piece of magnetic data on our planet. Every computer hard drive, every credit card, every piece of electronic equipment would be instantly erased. But that's not the truly terrifying part. If you somehow found yourself within 600 miles of a magnetar, something far worse would happen. The magnetic field would be so intense that it would overcome the electromagnetic forces holding your atoms together. You would literally be torn apart at the subatomic level, your very existence unraveled by forces beyond human comprehension. Astronomers recently discovered something even more disturbing about these cosmic nightmares. They've been tracking a particular magnetar called SGR 0501+4516, and what they found has left them baffled and deeply unsettled. This stellar zombie is hurtling through our galaxy at more than 110,000 miles per hour, and nobody knows where it came from or where it's going. The fact that it's moving at such incredible speeds suggests that it was ejected from its birthplace by some unimaginably violent event. Perhaps it was flung out during a supernova explosion, or maybe it was the result of a collision between neutron stars. But the most disturbing possibility is that we simply don't understand these objects well enough to predict their behavior. You see, magnetars aren't content to simply exist as cosmic zombies. They're active, violent, and capable of unleashing bursts of energy that can affect planets from distances of thousands of light years. In 2005, a magnetar located 50,000 light years from Earth erupted with such violence that it briefly altered our planet's upper atmosphere. The explosion lasted only 0.2 of a second, but it released more energy than our Sun produces in 150,000 years. The gamma rays from this distant explosion hit Earth's atmosphere with such intensity that they temporarily disrupted radio communications and caused several satellites to malfunction. If this had happened to a magnetar in our cosmic neighborhood, say within a few hundred light years, the results would have been catastrophic. The radiation would have stripped away our ozone layer, exposing all life on Earth to lethal ultraviolet radiation from the sun. But perhaps the most chilling aspect of magnetars is how they're born. For decades, scientists have been baffled by the transformation process that turns an ordinary neutron star into one of these magnetic monsters. They knew it happened, but they didn't understand how or why. That mystery may have been solved in the most terrifying way possible. Astronomers believe they've witnessed the birth of a magnetar for the first time, and what they saw suggests that these cosmic nightmares can appear anywhere, at any time, without warning. The process appears to involve the sudden reorganization of the neutron star's magnetic field, an event so violent that it can be detected from billions of light years away. This means that somewhere in our galaxy, perhaps even in our cosmic neighborhood, ordinary neutron stars may be undergoing this transformation right now. They could be evolving into magnetars as you listen to these words, acquiring the power to sterilize entire solar systems with bursts of radiation that travel at the speed of light. The implications are staggering. We live in a universe where the death of stars can create monsters so powerful that they threaten life across vast regions of space. These cosmic zombies wander through the darkness, their magnetic fields capable of destruction on a scale that makes our worst nightmares seem trivial by comparison. And the most terrifying part of all? We're only just beginning to understand how many of these monsters might be lurking out there in the infinite darkness, waiting to unleash their terrible power upon an unsuspecting cosmos. But Magnetars are just one face of cosmic horror. Let me tell you about something that makes even these magnetic monsters pale in comparison. Every single day, for just a few seconds at a time, our planet is bombarded by gamma rays created by explosions so powerful that they dwarf anything we can imagine. These are gamma ray bursts, and they represent the most violent events in the universe since the Big Bang itself. Picture this scenario, if you can bear to. Somewhere in a distant galaxy, a star dozens of times more massive than our sun reaches the end of its life. But this isn't the gentle fading we might hope for when our own sun dies billions of years from now. No, this is cosmic violence on a scale that defies description. The star's core collapses in less than a second, forming a black hole while simultaneously launching jets of material outward at nearly the speed of light. These jets, focused into narrow beams like cosmic searchlights, carry more energy than our sun will produce in its entire 10 billion year lifetime. When one of these beams sweeps across space, it creates what astronomers call a gamma ray burst. For a few brief moments, this explosion can outshine all the stars in its host galaxy combined, broadcasting its message of destruction across billions of light years. Here's what should keep you awake at night. If one of these cosmic death rays were pointed directly at Earth from anywhere within our galactic neighborhood, it would mean the end of life as we know it. The gamma radiation would hit our atmosphere like an invisible tsunami of death, obliterating our ozone layer within moments. Without this protective barrier, the sun's ultraviolet radiation would sterilize the surface of our planet, triggering a mass extinction event that would make the dinosaur-killing asteroid look like a gentle rain shower. But the immediate radiation blast would be just the beginning of our nightmare. The gamma rays would trigger chemical reactions in our atmosphere, creating nitrogen oxides that would further destroy what remained of the ozone layer. Models suggest that a nearby gamma ray burst could reduce our ozone protection by 75% in some regions, creating a hellish world where stepping outside during daylight would mean instant death from radiation poisoning. The long-term effects would be equally catastrophic. Ecosystems would collapse as the base of food chains died off. The altered atmospheric chemistry would trigger climate changes that could plunge the Earth into an ice age. Some scientists believe this may have already happened in our planet's history. The second largest mass extinction event, which occurred 440 million years ago, may have been caused by a gamma ray burst that struck Earth when these cosmic monsters roamed a younger, more violent universe. What makes gamma ray bursts even more terrifying is their unpredictability. Until recently, astronomers thought these explosions lasted only seconds or minutes. But in July of this year, NASA's Fermi Gamma Ray Space Telescope detected something that shattered their understanding. A gamma ray burst that refused to die, continuing for about 7 hours before finally fading into darkness. This discovery has opened up terrifying new possibilities about the cosmic violence that surrounds us. If gamma ray bursts can last for hours instead of seconds, it means the universe is capable of sustained destruction on a scale we never imagined. These prolonged death rays could sterilize not just individual planets, but entire regions of galaxies, creating cosmic dead zones where life could never take hold. The mathematics of our survival are sobering. Astronomers estimate that a civilization-ending gamma-ray burst occurs in our galaxy roughly once every few million years. In cosmic terms, that's frighteningly frequent. We exist in a universe where, at any moment, a star we've never heard of in a galaxy, whose name we don't know, could explode and end our story before we even knew the threat existed. Now, let me share with you something that will fundamentally change how you think about the space around you. You're sitting there right now, listening to my voice, completely unaware that you're surrounded by an invisible ocean of something that scientists can neither see nor touch, yet which dominates everything that exists. This isn't science fiction. This is the terrifying reality of dark matter. Everything you've ever seen, every star that twinkles in the night sky, every planet, every galaxy, every particle of ordinary matter that makes up your body and everything you've ever touched, represents less than 5% of the universe. The other 95% consists of dark matter and dark energy, invisible forces that shape reality in ways we're only beginning to comprehend. Think about that for a moment. The entire visible universe, with all its countless stars and galaxies, is nothing more than a tiny island of light in an ocean of darkness so vast it defies comprehension. We are the luminous exception in a universe dominated by invisible matter that we cannot see, cannot touch, and cannot directly detect, yet which exerts gravitational influence on everything around us. The horror of dark matter lies not just in its invisible nature, but in its overwhelming presence. Right now, as you sit there, dark matter particles are streaming through your body at incredible speeds. Billions upon billions of these phantom particles pass through every square inch of your skin every second, yet you feel nothing. They interact so weakly with ordinary matter that they might as well exist in a parallel universe, ghostly and untouchable. But here's what makes dark matter truly terrifying. Despite its ethereal nature, it's the invisible scaffolding that holds the universe together. Without dark matter, galaxies would fly apart. Stars would never have formed. The cosmic web of structure that spans the universe would collapse into chaos. We exist only because this invisible force shaped the cosmos in ways that made our existence possible. Astrophysicist Janna Levin puts it in terms that should chill you to the bone. There could be eddies and turbulences in the dark matter around us. Invisible storms we cannot perceive. If we could somehow see dark matter, we might discover that we're surrounded by tornadoes of invisible material swirling around us without our awareness. The space you think of as empty might be churning with invisible currents and streams of matter flowing in patterns we can't even imagine. The implications are staggering. We live our lives believing we understand our environment, that we can see and interact with everything that matters in our immediate vicinity. But dark matter reveals this to be a comforting illusion. The reality is that we exist as tiny, fragile bubbles of visible matter in a universe dominated by forces and materials we cannot perceive. Scientists have spent decades trying to detect dark matter directly, building increasingly sophisticated detectors deep underground, shielded from cosmic radiation and other interference. They've created chambers filled with liquid xenon, waiting for the telltale flash of light that would indicate a dark matter particle has finally interacted with ordinary matter. But despite decades of searching, dark matter continues to slip through our instruments like a ghost, leaving only its gravitational signature as evidence of its existence. This invisible dominance extends to an even more disturbing force that's actively tearing the universe apart. Dark energy, which makes up nearly 70% of everything that exists, is accelerating the expansion of space itself. Unlike dark matter, which at least has the courtesy to clump together and help form structures, dark energy is a relentless force of cosmic separation. Brian Schmidt, one of the astronomers who discovered dark energy, described his reaction to the discovery as somewhere between amazement and horror. Horror at the realization that an unknown force dominates the universe and determines its ultimate fate. This cosmic pressure is driving galaxies apart at an ever-increasing rate, ensuring that future civilizations will inherit a universe of profound loneliness. In the far future, dark energy will win its cosmic tug-of-war with gravity. Galaxies will become so distant from each other that their light will be redshifted beyond detection. Stars will exhaust their fuel and die without replacement. Eventually, even the atoms that make up matter may be torn apart by dark energy's relentless expansion. We exist at a unique moment in cosmic history, when the universe is old enough to have formed complex structures like galaxies and stars, but young enough that we can still observe the cosmic web that connects everything. Future civilizations, if they exist, will inherit a cold, dark, and increasingly empty universe, with no way to discover the rich cosmic history we're privileged to witness. But perhaps the most unsettling aspect of dark matter and dark energy is what they tell us about the limits of human knowledge. We've built particle accelerators that can recreate conditions from fractions of a second after the Big Bang. We've sent telescopes to the edge of the solar system and detected gravitational waves from colliding black holes billions of light years away. Yet 95% of the universe remains completely mysterious to us. This invisible majority could contain structures, phenomena, and forms of existence that we lack even the concepts to describe. There could be entire ecosystems of dark matter interactions playing out around us, invisible civilizations built from particles we cannot detect, or cosmic processes so alien that our physics has no framework for understanding them. We are explorers in a universe where most of the territory is not just unmapped, but invisible. The cosmic horror isn't just that dangerous things lurk in the darkness between stars. It's that the darkness itself is alive with invisible forces and materials that dwarf everything we can see and touch, yet remain forever beyond our reach. Now, as we venture deeper into this cosmic chamber of horrors, we encounter something that challenges our most basic understanding of planetary worlds. Imagine, if you will, a place so alien, so fundamentally hostile to existence, that it makes the harshest environments on Earth seem like tropical paradises. Welcome to the nightmare realm of exoplanets, where the universe has crafted worlds of such exquisite terror that they defy our wildest imagination. Consider HD 189733b, a world that appears deceptively beautiful when viewed through our most powerful telescopes. From a distance, this alien planet glows with a stunning cobalt blue color that might remind you of Earth's oceans seen from space. But this resemblance to our home world is nothing more than a cosmic joke, a cruel deception that masks one of the most hellish environments ever discovered. The blue glow doesn't come from water or peaceful skies. Instead, it's created by clouds of silicate particles suspended in an atmosphere so violent it defies comprehension. The surface temperature reaches 1300 degrees Celsius, hot enough to melt copper. But temperature is the least of this world's terrors. The planet is constantly battered by winds that scream across its surface at nearly 9,000 kilometers per hour, carrying with them a payload that transforms weather into weaponry. You see, on HD 189733b, it doesn't rain water, it rains molten glass. Imagine glass heated to temperatures that would instantly vaporize any earthly material, then hurled sideways by winds moving at speeds that dwarf the most powerful hurricanes ever recorded on Earth. This glass rain doesn't fall gently from the sky. Instead, it's launched horizontally like cosmic bullets, creating a perpetual storm of molten silicate projectiles that would shred anything foolish enough to exist on this world's surface. But HD 189733b is merely one example of the cosmic horror show that awaits us among the thousands of exoplanets discovered in recent years. Each new world we find seems designed to showcase the universe's capacity for creating environments so hostile that they challenge our understanding of what constitutes a planet at all. Take JWST 12b, a world so close to its parent star that it's literally being devoured alive. This unfortunate planet orbits its star so closely that the intense gravitational forces are stretching it into an elongated, egg-like shape while simultaneously stripping away its atmosphere. The planet is hemorrhaging material at such a catastrophic rate that it will completely vanish within 10 million years, consumed entirely by the very star that gave it light. The process is both beautiful and horrifying to contemplate. As JWST 12b spirals ever closer to its stellar parent, its atmosphere is torn away in streaming ribbons of hot gas that form a glowing trail behind the doomed world. It's like watching a cosmic vampire slowly drain the life from its victim, except the timescale is measured in geological epochs rather than moments. But perhaps no world encapsulates the universe's capacity for creating cosmic nightmares quite like TRES-2b, a planet that exists in a state of perpetual darkness so complete it makes the deepest cave on Earth seem brightly lit by comparison. This world absorbs more than 99% of all light that strikes it, making it darker than charcoal, darker than the blackest paint ever created by human hands. What makes TRES-2b truly terrifying isn't just its supernatural darkness, but the contradiction it presents. Despite absorbing virtually all light, the planet maintains temperatures hot enough to melt copper. This creates a world of absolute blackness, heated to infernal temperatures, a realm where darkness itself seems to burn with invisible fire. The very physics of this world challenges our understanding of how planets should behave, creating a cosmic anomaly that seems pulled from the pages of supernatural horror. Scientists struggle to explain how TRES-2b maintains such extreme darkness while remaining so incredibly hot. The leading theories involve atmospheres containing exotic compounds like vaporized sodium and titanium oxide, materials that create a kind of cosmic light trap, absorbing photons so efficiently that almost nothing escapes back into space. It's a world where the normal rules of reflection and radiation seem to have been suspended, replaced by mechanisms so alien we barely have the vocabulary to describe them. But exoplanets don't just challenge our understanding of worlds. They reveal the universe's capacity for recycling cosmic violence into new forms of terror. Deep in space, orbiting the pulsar designated PSR B1257+12, exist planets with perhaps the most disturbing origin story ever discovered. These worlds didn't form through the gentle accretion of cosmic dust and gas that created Earth. Instead, they were born from the ashes of stellar death, forged in the aftermath of one of the most violent explosions the universe can produce. When the massive star that became PSRB 1257+12 exploded in a supernova, it should have destroyed everything in its vicinity. The explosion should have vaporized any existing planets and sterilized the surrounding space of all matter. Yet somehow, from this cosmic crematorium, new worlds arose like phoenixes from nuclear fire. These pulsar planets represent a form of planetary resurrection so bizarre that astronomers initially refused to believe they could exist. The environment on these worlds defies every notion we have of what constitutes a habitable or even survivable planetary surface. The pulsar that serves as their sun is a stellar corpse that spins 30 times per second, emitting beams of radiation so intense they can be detected across thousands of light years of space. These beams sweep across the pulsar planets like cosmic lighthouses, except instead of guiding ships to safety, they deliver doses of radiation that would instantly sterilize any conceivable form of life. Living on a pulsar planet would be like existing inside a microwave oven that's also being bombarded by the most intense X-ray machine ever conceived. The radiation levels are so extreme that they would break apart the molecular bonds holding organic compounds together, making any form of chemistry-based life utterly impossible. Yet these worlds persist, orbiting their undead star in a cosmic dance of death that continues for billions of years. The discovery of pulsar planets forced astronomers to confront a disturbing truth about the universe's capacity for creating order from chaos. Even the most violent cosmic events, explosions capable of briefly outshining entire galaxies, cannot completely sterilize space. Instead, they transform it, creating new forms of worlds so alien that they stretch our definitions of what planets can be. But if hot worlds and irradiated wastelands represent one face of cosmic horror, then the Boomerang Nebula represents its opposite extreme. Located in the constellation Centaurus, this stellar graveyard holds the distinction of being the coldest known place in the universe, with temperatures that approach absolute zero at just 1 degree Kelvin above the theoretical limit where all atomic motion ceases. The Boomerang Nebula is what happens when a dying star becomes a cosmic refrigerator. As the central red giant expels its outer layers, the expanding gas cools so rapidly that it creates temperatures colder than the cosmic microwave background radiation itself. This is a place where the normal laws of thermodynamics seem to have been suspended, where heat death takes on literal meaning. In this frozen hell, any matter would instantly crystallize and shatter. The cold is so intense that it approaches the fundamental limits of temperature itself, creating conditions where the very concept of heat becomes meaningless. It's a cosmic deep freeze that makes the coldest places on Earth seem tropical by comparison. The Antarctic Plateau, Earth's coldest natural environment, is nearly 3 times warmer than this stellar morgue. What makes the Boomerang Nebula particularly disturbing is its beauty. When viewed through powerful telescopes, it appears as an ethereal hourglass of glowing gas, illuminated by starlight into patterns of stunning complexity. This visual splendor masks the fact that it represents one of the most hostile environments imaginable, a place where the fundamental processes that allow atoms to interact and chemistry to occur have been frozen into stillness. The nebula's ghostly appearance comes from light scattered by microscopic dust particles suspended in the expanding gas cloud. These particles, cooled to temperatures that approach absolute zero, create an otherworldly landscape of cosmic ice sculptures formed from the death throes of a star. It's simultaneously beautiful and terrifying, a reminder that the universe's most aesthetically stunning phenomena often conceal the most inhospitable conditions imaginable. But perhaps the most unsettling aspect of these extreme worlds is what they tell us about the universe's indifference to life as we understand it. Every exoplanet discovery, every extreme environment we uncover, reinforces the reality that Earth's gentle climate and stable conditions are not the cosmic norm. Instead, they represent an almost miraculous exception in a universe dominated by worlds where existence itself seems to be under constant assault. The sheer diversity of hostile environments we've discovered suggests that the universe is far more creative in its capacity for destruction than we ever imagined. From worlds where glass rain falls sideways through atmosphere heated to stellar temperatures, to frozen graveyards where atoms themselves approach motionlessness. Each new discovery expands our catalogue of cosmic nightmares. Yet these discoveries also reveal something profound about the resilience of cosmic processes. Even in the most extreme environments, planets form, atmospheres develop, and complex systems emerge. The universe may be hostile to life, but it's incredibly fertile when it comes to creating new forms of worlds, each one a unique experiment in the physics of matter under extreme conditions. As we continue to discover new exoplanets and study their properties, we're forced to confront an uncomfortable truth. The gentle blue world we call home may be far more unusual than we ever dared imagine. In a universe filled with worlds of glass rain and frozen stellar graveyards, with planets being devoured by their stars and others bathed in lethal radiation, Earth begins to look less like the natural result of planetary formation and more like a cosmic miracle. The horror isn't just that these nightmare worlds exist, it's that they vastly outnumber places like Earth, suggesting that in the grand cosmic lottery of planetary formation, we may have won the only prize that allows observers to exist and contemplate their good fortune. We are inhabitants of an oasis in a desert of hostile worlds, surrounded by cosmic environments so alien and dangerous that they challenge our understanding of what it means for a world to exist at all. And yet, even as we catalogue these cosmic chambers of horror, new discoveries continue to push the boundaries of what we thought possible. The universe, it seems, has barely begun to show us the full extent of its capacity for creating worlds, where existence itself becomes a form of cosmic joke, played out against the backdrop of an indifferent cosmos that continues to surprise us with new forms of beautiful, terrible impossibility. But even as we catalogue these nightmarish worlds and their impossible conditions, the universe reserves its most chilling revelations for something far closer to home. Our own sun, that gentle provider of warmth and light that makes all life on Earth possible, harbours within its fusion-powered heart the capacity to become our destroyer. You see, we live under the benevolent gaze of what is essentially a controlled nuclear explosion, a star that maintains a delicate balance between the crushing force of gravity trying to collapse it and the outward pressure of fusion reactions trying to blow it apart. For billions of years, our sun has maintained this cosmic equilibrium with remarkable stability. But like all stars, It's subject to violent mood swings that can unleash devastation across the solar system. These stellar tantrums are called solar superstorms, and they represent one of the most immediate cosmic threats to our technological civilization. When our Sun experiences a particularly violent magnetic field reorganization, it can hurl billions of tons of charged particles into space at speeds approaching 3 million miles per hour. These coronal mass ejections race across the solar system like invisible tsunamis of electromagnetic destruction. The last time Earth experienced a truly massive solar superstorm was in 1859, an event known as the Carrington event. Telegraph lines around the world sparked and caught fire. Aurora displays were visible as far south as the Caribbean. Telegraph operators received electric shocks, and some telegraph systems continued to function even after being disconnected from their power sources, running purely on the induced electrical currents from the magnetic storm. But here's what should terrify you about the Carrington event. In 1859, human civilization had barely begun its love affair with electricity. We had no satellites, no power grids spanning continents, no computers, no internet, no GPS systems. Today, a Carrington-level solar superstorm would be nothing short of an electromagnetic apocalypse. Computer simulations suggest that such an event would destroy virtually every satellite in orbit around Earth. Our GPS navigation systems would fail instantly. The internet would collapse as undersea cables and communication networks succumbed to the induced electrical currents. Power grids across entire continents would shut down as transformers overloaded and caught fire. The electromagnetic pulse would fry electronic systems on a global scale, potentially throwing human civilization back into a pre-electronic age overnight. The economic damage from such an event has been estimated at over $2 trillion, but the true cost would be measured in human suffering. Hospitals would lose power, air traffic control systems would fail, financial markets would collapse, food distribution networks would break down, water treatment facilities would stop functioning. Within days, modern cities would become uninhabitable as the complex technological infrastructure that supports millions of people simply ceased to exist. What makes solar superstorms particularly terrifying is their unpredictability. The Sun operates on cycles that we're only beginning to understand, with magnetic field reversals occurring roughly every 11 years. But within these cycles, massive ejections can happen with little warning. We might have anywhere from 18 hours to 4 days notice before the electromagnetic death wave reaches Earth, barely enough time to shut down critical systems and hope for the best. Recent studies have revealed that our Sun is capable of far more violence than the Carrington event represents. In 2012, Earth narrowly missed what scientists describe as a civilization-ending solar storm. A coronal mass ejection of unprecedented power erupted from the Sun's surface, racing through the location in Earth's orbit where our planet had been just 1 week earlier. If this cosmic bullet had been fired when Earth was in its path, the results would have been catastrophic beyond imagination. The magnetic field strength of this near-miss event was measured at over 3,000 nanotesla, nearly twice as powerful as the Carrington event. Computer models suggest that such a storm would have caused widespread power grid failures lasting months or even years. The aurora displays would have been visible at the equator. Electronic devices across the planet would have been permanently damaged by the induced electrical currents. But solar superstorms represent just one face of our sun's capacity for cosmic violence. Deep within its fusion core, our parent star is constantly undergoing processes so extreme that they challenge our understanding of matter itself. Every second, the sun converts over 4 million tons of matter into pure energy through nuclear fusion, releasing the equivalent of billions of hydrogen bombs. This process creates neutrinos, ghostly particles that barely interact with matter, yet are produced in such staggering quantities that trillions of them pass through your body every second. While these solar neutrinos are largely harmless, they represent a constant reminder that we live at the mercy of a nuclear furnace whose power output could sterilize our planet if it experienced even minor fluctuations in its energy production. The sun's magnetic field lines, twisted and tangled by the differential rotation of the stellar plasma, occasionally snap and reconnect with explosive violence. These magnetic reconnection events release energy equivalent to billions of nuclear weapons, hurling charged particles into space at relativistic speeds. When these particles interact with Earth's magnetosphere, they create the beautiful aurora displays we admire. But they also represent a constant bombardment of radiation that would be lethal to any life form not protected by our planet's magnetic field. Yet even our magnetic field, that invisible shield that deflects most of the sun's particle radiation, is not a permanent feature of our world. The Earth's magnetic field has reversed many times throughout geological history, and during these reversals, the protective barrier can weaken dramatically or even disappear entirely for periods of hundreds or thousands of years. During these magnetic field reversals, Earth would be essentially defenseless against solar radiation. Even minor solar storms would become deadly, bombarding the surface with particles that would cause radiation sickness and genetic damage to any life forms caught in the open. The ozone layer would be stripped away by the constant particle bombardment, exposing the surface to lethal ultraviolet radiation from the sun. Some scientists believe that magnetic field reversals may have contributed to past mass extinction events on Earth. The fossil record shows correlations between periods of magnetic instability and the disappearance of species, suggesting that our protective magnetic shield is more fragile and variable than we might hope. But the sun's capacity for destruction extends far beyond electromagnetic storms and particle radiation. As our parent star ages over the next 5 billion years, it will gradually increase in brightness and temperature. This stellar evolution will eventually make Earth uninhabitable long before the sun exhausts its nuclear fuel and begins its death throes. In roughly 1 billion years, the sun's increasing luminosity will cause Earth's oceans to boil away entirely. The water vapor in our atmosphere will trap heat so efficiently that our planet will experience a runaway greenhouse effect similar to what has already occurred on Venus. Surface temperatures will rise to over 800 degrees Fahrenheit, hot enough to melt lead. Any life that has managed to survive until that point will be sterilized by the heat. But this gradual cooking is merely the prelude to the sun's final act of cosmic violence. When our star finally exhausts the hydrogen fuel in its core, it will begin burning heavier elements in its outer layers. This will cause the sun to expand into a red giant, growing so large that its outer atmosphere may extend beyond Earth's current orbit. Even if our planet manages to avoid being directly engulfed by the expanding sun, the increased stellar radiation will turn Earth into a molten ball of rock. The atmosphere will be blasted away into space. The oceans will have long since boiled away. Any trace of the biosphere that once flourished on our world will be erased, as if it had never existed. This stellar death dance will play out over hundreds of millions of years, but from a cosmic perspective, it represents merely a brief flicker in the life of the universe. Our Sun, along with its family of planets, will join the countless other stellar systems that have lived and died throughout cosmic history, leaving behind only a white dwarf star slowly cooling in the darkness of space. The realization that our Sun, the source of all warmth and energy that makes life possible, is also the agent of our ultimate destruction, adds a particularly cruel irony to our cosmic situation. We exist entirely at the mercy of a nuclear furnace that could destroy us tomorrow with a massive coronal mass ejection, or slowly cook us over the course of billions of years as it follows its inevitable stellar evolution. Yet even as we contemplate the various ways our Sun might end our story, we must confront an even more immediate and numerous threat lurking in the darkness around us. Our solar system, that seemingly orderly arrangement of planets orbiting peacefully around our star, is actually embedded in a cosmic shooting gallery filled with rocky projectiles traveling at devastating speeds. The recent discovery by the European Space Agency's Gaia Space Telescope has revealed a truth that should make anyone concerned about Earth's long-term survival deeply uncomfortable. There are approximately 10 times more asteroids in our solar system than astronomers previously thought. While we've identified most of the planet-killing objects, those massive asteroids larger than a kilometer in diameter that could trigger global extinction events. The revelation of countless smaller objects means that city-destroying impacts remain a constant and poorly understood threat. These cosmic bullets travel through space at velocities that can exceed 20 kilometers per second, carrying kinetic energy that transforms even relatively small rocks into weapons of mass destruction. An asteroid just 50 meters across, barely the size of a city block, carries enough energy to devastate an area the size of a large metropolitan region when it strikes Earth's surface or explodes in the atmosphere. The mathematics of impact energy are sobering. A rocky projectile weighing just a few thousand tons, moving at typical asteroid speeds, carries the destructive power of multiple nuclear weapons. But unlike nuclear weapons, these cosmic missiles give no warning of their approach. They emerge from the darkness of space, often from directions that make them nearly impossible to detect until they're almost upon us. Recent near-miss events have demonstrated just how vulnerable our planet remains to these cosmic threats. In 2013, an asteroid roughly 20 meters in diameter exploded over the Russian city of Chelyabinsk with the force of 30 Hiroshima bombs. The shockwave damaged thousands of buildings and injured over 1,500 people. Yet this object was too small to have been detected by most asteroid monitoring systems. The Chelyabinsk event was a wake-up call that revealed the gaps in our asteroid detection capabilities. While we've catalogued most of the massive planet killers that could end human civilization, we've barely begun to identify the smaller objects that could devastate cities or regions. These intermediate-sized asteroids, ranging from tens to hundreds of meters across, represent a largely invisible threat population that could strike with little or no warning. What makes the asteroid threat particularly unsettling is its random nature. Unlike solar storms, which follow somewhat predictable cycles, or stellar evolution, which operates over geological timescales, Asteroid impacts can happen at any moment. There may be a city-killer asteroid on a collision course with Earth right now, hidden in the sun's glare, or approaching from a direction that makes it invisible to our current detection systems. The gravitational influence of Jupiter and other planets constantly perturbs asteroid orbits, occasionally sending objects from the asteroid belt on trajectories that cross Earth's path. These orbital changes can happen over periods of thousands or millions of years, meaning that asteroids which have been harmlessly orbiting the Sun for billions of years can suddenly become threats to our planet. Computer simulations of asteroid populations suggest that Earth experiences major impacts far more frequently than the geological record indicates. Many impact craters have been erased by erosion, plate tectonics, and other geological processes, meaning that our planet's bombardment history is likely far more violent than we can directly observe. The discovery of impact structures hidden beneath ice sheets and sedimentary layers continues to reveal new evidence of cosmic collisions throughout Earth's history. Each new crater discovered pushes the estimated frequency of major impacts higher, suggesting that we live on a planet that has been repeatedly struck by cosmic projectiles throughout its existence. But perhaps the most disturbing aspect of the asteroid threat is how it connects to the broader violence of our cosmic neighborhood. The asteroid belt itself is thought to be the remains of a planet that failed to form, its material scattered by gravitational interactions into countless rocky fragments. These fragments represent the construction debris left over from the formation of our solar system, but they also serve as a constant reminder that planetary formation is a violent process that leaves behind dangerous remnants. The recent close approach of several large asteroids has provided astronomers with detailed observations of these cosmic visitors, and what they've discovered is deeply unsettling. Many asteroids are not solid rocks, but rather loose collections of rubble held together by their own weak gravity. These rubble pile asteroids are particularly difficult to deflect because they lack the structural integrity to respond predictably to impacts or gravitational nudges. Some asteroids rotate so rapidly that they should fly apart under centrifugal force, yet somehow maintain their structural integrity through mechanisms that scientists don't fully understand. Others have been found to have their own tiny moons, creating miniature gravitational systems that add complexity to any potential deflection efforts. The composition of asteroids varies dramatically, from metallic objects that are essentially flying mountains of iron and nickel, to carbonaceous asteroids rich in organic compounds and water. Some contain rare metals and minerals that don't exist naturally on Earth, suggesting that they formed in regions of the solar system with very different conditions than those that created our planet. These compositional differences have implications for the damage that asteroid impacts might cause. Metallic asteroids are much denser and would cause more localized but intense damage upon impact. Carbonaceous asteroids might disintegrate more readily in the atmosphere, spreading their energy over a wider area, but potentially delivering toxic compounds across vast regions. The realization that our solar system contains 10 times more asteroids than previously thought transforms our understanding of Earth's cosmic neighborhood from a relatively safe haven to a dangerous shooting gallery where high-velocity projectiles constantly threaten our planet's surface. We exist on a world that has been shaped by cosmic violence, and that violence continues around us every day, largely invisible but always present. As we peer deeper into the cosmic abyss that surrounds our small island of life, we encounter phenomena that challenge not just our understanding of physics, but our fundamental assumptions about the nature of existence itself. Hidden in the vast spaces between stars are structures so alien and disturbing that they force us to confront the possibility that the universe contains forms of matter and energy that operate according to rules we haven't even begun to discover. These are the dark nebulae, cosmic shadows that represent some of the most psychologically disturbing features of our universe. Unlike the glowing nebulae that grace astronomy textbooks with their ethereal beauty, dark nebulae are regions where light simply ceases to exist. They appear as voids against the star-filled background of space, cosmic blind spots where entire stellar systems could be hidden from view. What makes dark nebulae particularly unsettling isn't just their ability to block light, but their potential to conceal unknown cosmic phenomena. These structures can span hundreds of light years across, creating vast regions where our observational capabilities become useless. Behind these cosmic curtains, entire populations of stars, planets, and possibly even more exotic objects could exist without our knowledge. The psychological impact of dark nebulae goes beyond their observational limitations. They represent the universe's capacity to hide its secrets behind veils of cosmic dust and gas so thick that even the most powerful telescopes cannot penetrate them. In a cosmos where knowledge and observation are our only tools for understanding our place in the universe, these structures represent absolute barriers to comprehension. Some dark nebulae are so dense that they contain the raw materials for thousands of future stars, yet appear completely empty when viewed through optical telescopes. Only when astronomers observe them in infrared wavelengths do these apparently barren regions reveal themselves to be stellar nurseries where new suns are being born in the darkness. The contrast between their empty appearance and their active reality creates a profound sense of cosmic deception. But perhaps the most disturbing aspect of dark nebulae is what they tell us about the limitations of human perception. We've built our understanding of the universe based on light, on the assumption that electromagnetic radiation can carry information about distant objects across space and time. Dark nebulae represent places where this fundamental assumption breaks down, where the universe becomes literally invisible to our primary method of cosmic exploration. The existence of these cosmic blind spots raises disturbing questions about what else might be hidden from our view. If entire regions of space can be concealed behind curtains of dust and gas, what other phenomena might exist that we simply cannot detect with our current technology? Could there be forms of matter or energy that don't interact electromagnetically at all, remaining forever invisible no matter how sophisticated our instruments become? Recent discoveries have revealed that some dark nebulae contain magnetic fields so complex and powerful that they can influence star formation across vast regions of space. These invisible magnetic structures create a kind of cosmic architecture that shapes the birth and evolution of stellar systems, yet remains largely undetectable, except through its subtle effects on the matter around it. The realization that magnetic fields can dominate entire regions of space adds another layer of invisibility to our cosmic environment. We exist in a universe where invisible forces can control the formation of stars and planets across distances of hundreds of light years, operating through mechanisms that we're only beginning to understand. But dark nebulae represent just one form of cosmic concealment. Throughout the galaxy, there exist objects so alien to our experience that they challenge our basic categories of cosmic classification. These are the vampire stars, binary systems where one stellar partner feeds off the other in a process so disturbing that astronomers initially struggled to believe such systems could exist. In these cosmic horror scenarios, a dead white dwarf star, the collapsed remnant of a sun-like star, slowly strips material from a living companion. The white dwarf's intense gravity pulls streams of gas from the surface of the donor star, creating spiraling accretion disks of superhot material that glow with the stolen energy of stellar cannibalism. What makes vampire star systems particularly disturbing is their capacity for resurrection. The dead white dwarf, which should remain cold and inert for billions of years, can spring back to violent life when it accumulates enough stolen material from its victim. This accumulated matter eventually triggers a thermonuclear explosion called a nova, briefly outshining normal stars by factors of thousands or even millions. But the white dwarf survives this explosion, having only blown away the surface material it stole from its companion. The system then settles back into its parasitic relationship, with the undead star continuing to feed off its living partner until enough material accumulates for another explosive outburst. Some vampire star systems undergo this resurrection cycle repeatedly over millions of years, creating a cosmic pattern of death, feeding, explosion, and renewal that defies our normal understanding of stellar evolution. The discovery of vampire stars revealed that stellar death is not always final. Under the right circumstances, dead stars can return to active life by consuming their companions, transforming stellar graveyards into scenes of ongoing cosmic violence. This challenges our understanding of stellar evolution as a one-way process from birth through death, revealing instead a universe where the boundaries between life and death become blurred. Some vampire star systems eventually consume their partners entirely, leaving behind only the swollen white dwarf and the scattered remnants of what was once a living star. These cosmic crime scenes can persist for billions of years, serving as monuments to stellar murder that occurred long before our solar system even formed. But vampire stars represent just one example of the universe's capacity for stellar violence. Throughout our galaxy, there exist systems where stars don't just feed on each other, but engage in complex gravitational dances that can tear apart entire stellar families. Triple and quadruple star systems can undergo chaotic interactions that eject some members at high velocities while causing others to spiral inward toward collision. These stellar interactions can create some of the most violent events in the galaxy, producing explosions that briefly outshine entire galactic regions. When two white dwarf stars collide, they can trigger Type Ia supernovae, explosions so standardized in their energy output that astronomers use them as cosmic distance markers. Yet each of these standard candles represents the complete annihilation of two stellar remnants in a collision so violent it can be detected across billions of light years. The more we study the stellar populations of our galaxy, the more we discover that peaceful, stable star systems like our own are the exception rather than the rule. Most stars exist in complex multiple systems where gravitational interactions create ongoing instability and the potential for catastrophic events. We orbit a remarkably well-behaved star in a stellar neighborhood that has remained stable for billions of years, yet we're surrounded by systems where cosmic violence is the norm. The realization that stellar cannibalism and collision are common features of our galaxy adds yet another layer to the cosmic horror that surrounds us. Even the stars themselves, those distant suns that appear so constant and eternal from our earthbound perspective, exist in a universe where predation, violence, and sudden death are fundamental aspects of cosmic existence. As we continue our journey through the catalogue of cosmic terrors, we approach something that represents perhaps the most profound existential threat to human understanding. We've explored individual objects and phenomena that can destroy planets, sterilize solar systems, or consume entire stars. But now we must confront discoveries that threaten something even more fundamental than physical existence. They threaten the very framework through which we understand reality itself. The James Webb Space Telescope, humanity's most ambitious window into the cosmic depths, has begun transmitting images and data that have left even the most seasoned astronomers questioning everything they thought they understood about the universe. What should have been a triumph of scientific achievement has instead become a source of profound unease, revealing cosmic truths so disturbing that some physicists have described them as a crisis in our understanding of reality itself. You see, when we launched this magnificent instrument into the darkness beyond Earth's atmosphere, we expected it to confirm our existing models of cosmic evolution, to show us the early universe developing according to the elegant mathematical frameworks we'd spent decades constructing. Instead, JWST has revealed a cosmos that seems to operate according to rules we haven't even begun to comprehend, displaying structures and phenomena that shouldn't exist according to our current understanding of physics. The telescope's infrared vision, designed to peer deeper into space and further back in time than any previous instrument, has uncovered ancient galactic structures that formed far too early in cosmic history. These primordial galaxies appear massive, organized, and mature at times when the universe should have been a chaotic soup of elementary particles still cooling from the Big Bang's aftermath. It's as if we've discovered medieval cathedrals in archaeological layers that should contain only primitive cave paintings. But the temporal impossibilities revealed by JWST represent just the beginning of a deeper cosmic horror. The telescope has detected what appear to be interactions between visible matter and the invisible dark matter that dominates our universe, creating ghostly structures that exist at the boundary between the observable and the unknowable. These cosmic phantoms seem to operate according to physics we cannot yet describe, following patterns that suggest dark matter may be far more complex and active than we ever imagined. The implications are staggering and deeply unsettling. If dark matter can create organized structures and interact with itself in ways we don't understand, then the invisible majority of our universe may be teeming with phenomena that exist entirely beyond our ability to perceive or comprehend. We may be surrounded by entire ecosystems of dark matter interactions, cosmic civilizations built from particles we cannot detect, or processes so alien that our physics lacks even the conceptual framework to acknowledge their existence. Recent JWST observations have revealed what astronomers are calling galactic ghosts, ancient structures that appear to be the remnants of cosmic events so violent and incomprehensible that they've left scars in the fabric of space itself. These ethereal formations seem to exist at the intersection of multiple dimensions, visible only through their subtle gravitational effects on the matter around them. They represent a form of cosmic archaeology that reveals a universe far stranger and more violent than our most pessimistic theories had predicted. What makes these discoveries particularly disturbing is their implications for our cosmic neighborhood. If the early universe was capable of creating structures that defy our current understanding of physics, what other impossible phenomena might exist in the space around us? Could there be invisible architectures built from dark matter surrounding our solar system? Might we be embedded in cosmic structures so alien that we lack the sensory apparatus to detect them? The telescope has also revealed evidence of what some scientists are calling cosmic predation on scales previously unimaginable. Entire galactic clusters appear to be in the process of being consumed by invisible forces, their matter and energy being siphoned away by mechanisms that operate outside the boundaries of known physics. These cosmic vampires seem to feed on the very structure of space and time itself, growing stronger as they devour the organized matter that makes up galaxies and star systems. But perhaps the most chilling discovery JWST has made involves the detection of cosmic voids that appear to be actively expanding, consuming the matter and energy around them like three-dimensional black holes that operate according to unknown principles. These expanding emptiness zones seem to erase not just matter, but the very possibility of existence itself, creating regions where the normal laws of physics simply cease to function. The psychological impact of these discoveries on the scientific community cannot be overstated. Astronomers who dedicated their careers to understanding cosmic evolution now find themselves confronting evidence that suggests the universe operates according to principles so alien that our entire scientific framework may be nothing more than a local approximation, valid only in our tiny corner of a cosmos that extends far beyond the boundaries of human comprehension. Yet even as JWST reveals these cosmic impossibilities, we must confront an even more immediate and visceral threat that emerges from the darkness between stars. Throughout our galaxy, there exist stellar remnants so bizarre and powerful that they represent a form of cosmic undeath that challenges our understanding of what it means for a star to die. These are the stellar zombies that refuse to rest quietly in their cosmic graves, instead becoming predators that hunt through the galactic darkness with weapons that can destroy matter at the subatomic level. We've already discussed magnetars, those neutron stars with magnetic fields, powerful enough to strip atoms apart from hundreds of miles away. But recent discoveries have revealed that these stellar zombies come in varieties so exotic that they stretch our definitions of what constitutes matter itself. Some neutron stars spin so rapidly that they approach the theoretical limits of structural integrity, rotating hundreds of times per second, while somehow maintaining their coherence through mechanisms that physicists are still struggling to understand. These millisecond pulsars, as astronomers call them, represent a form of stellar resurrection that transforms the corpses of dead stars into cosmic engines of unimaginable precision and power. Their rotation is so stable that they serve as the most accurate clocks in the universe, more precise than atomic timepieces. Yet they achieve this temporal perfection while existing in states of matter so extreme that they defy conventional physics. The surfaces of these rapidly spinning neutron stars experience gravitational forces billions of times stronger than anything on Earth, creating conditions where matter exists in phases that cannot be replicated in any laboratory. The magnetic fields generated by their rapid rotation accelerate particles to near light speed, creating beams of radiation that sweep across space like cosmic lighthouses, broadcasting messages of stellar death across thousands of light years. But some neutron stars exhibit behavior so bizarre that they challenge our understanding of causality itself. These objects, known as glitching pulsars, occasionally experience sudden changes in their rotation rate that seem to violate the laws of physics. In a fraction of a second, these stellar zombies can spin up or slow down by amounts that should require millions of years of gradual change, as if they were responding to commands from some unknown cosmic intelligence. The mechanism behind these glitch events remains one of the most disturbing mysteries in astrophysics. Some theories suggest that the solid crust of the neutron star occasionally cracks under the immense gravitational stress, allowing the interior to readjust its rotation rate. But other observations suggest something far more unsettling: the possibility that these stellar corpses exist in quantum states that allow them to tunnel between different rotational configurations instantaneously. If neutron stars can indeed exist in quantum superposition states, switching between different rotational speeds through mechanisms that bypass normal causality, then these stellar zombies represent a form of macroscopic quantum phenomenon that should be impossible according to our current understanding of physics. They would be objects massive enough to warp space and time, yet capable of quantum behavior that normally applies only to subatomic particles. The implications extend far beyond stellar physics. If matter can exist in quantum superposition states at neutron star scales, what other macroscopic quantum phenomena might exist in the universe? Could entire planets or star systems exist in multiple states simultaneously? Might there be regions of space where the normal boundaries between quantum and classical physics break down entirely? Recent observations have revealed neutron stars that seem to exist in multiple locations simultaneously, their radiation signatures appearing to come from several different positions in space at the same time. These quantum ghosts challenge our most basic assumptions about the nature of matter and existence, suggesting that the universe may be fundamentally more mysterious and non-local than even quantum mechanics had prepared us to believe. But neutron star quantum behavior represents just one face of stellar undeath. Throughout the galaxy, there exist white dwarf stars that have undergone transformations so bizarre that they seem to operate according to rules borrowed from supernatural horror rather than astrophysics. These crystallized stellar remnants, composed of matter compressed to densities that approach the theoretical limits of atomic structure, can undergo phase transitions that transform them into cosmic entities, unlike anything in our terrestrial experience. Some white dwarfs have been discovered with surface temperatures that fluctuate in patterns that seem to suggest internal processes more complex than simple cooling. These thermal oscillations create white dwarf stars that pulse with rhythms reminiscent of cosmic heartbeats, as if the stellar corpses were somehow maintaining a form of undead metabolism that operates on timescales of thousands of years. The discovery of crystalline white dwarfs has revealed that stellar death can produce forms of matter that exist at the boundary between solid and plasma states. These stellar crystals maintain temperatures of tens of thousands of degrees while exhibiting structural properties similar to enormous diamonds, creating objects that are simultaneously molten and solid, liquid and crystalline, defying the normal categories we use to classify states of matter. But perhaps the most disturbing white dwarf discoveries involve objects that seem to be aging backward, becoming hotter and more active over time, rather than cooling toward the cosmic background temperature as stellar evolution models predict. These rejuvenating stellar corpses appear to be drawing energy from unknown sources, possibly through interactions with dark matter or dark energy that we cannot yet detect or understand. The existence of white dwarfs that grow younger rather than older suggests that stellar death may not be the one-way process we assumed. If dead stars can reverse their cooling and return to active states through mechanisms we don't comprehend, then the universe may be filled with stellar zombies that can resurrect themselves repeatedly over cosmic timescales. Some of these anomalous white dwarfs have been observed to emit radiation patterns that seem to encode information in ways that suggest intelligence or purpose. While no serious scientist claims these signals represent communication from stellar civilizations, the organized nature of the emissions challenges our understanding of how dead stars should behave. The possibility that stellar corpses might develop emergent properties that mimic intelligence represents a form of cosmic horror that extends beyond physical threats into the realm of existential uncertainty. As we continue to discover new varieties of stellar undeath, from quantum neutron stars that exist in multiple states simultaneously to crystalline white dwarfs that age backward, we're forced to confront the possibility that death itself may operate according to different rules in the cosmic environment than it does on Earth. The universe may be filled with forms of existence that transcend our biological categories of life and death, creating realms where matter and energy can persist in states that challenge our most fundamental assumptions about the nature of reality. Yet even as we struggle to comprehend the implications of stellar zombies and quantum ghosts, the universe reserves its most profound terrors for phenomena that operate on scales so vast they dwarf even galactic structures. Hidden in the cosmic web that connects all matter across billions of light years, there exist supervoids, regions of space so empty that they seem to represent holes in reality itself. These cosmic deserts stretch across distances that can encompass thousands of galaxies, yet contain almost nothing but empty space and the occasional isolated star system drifting through the darkness like cosmic castaways. The largest known supervoid, called the cold spot, spans nearly 2 billion light-years across, creating a region of space so empty that light takes longer to cross it than human civilization has existed. What makes supervoids particularly disturbing isn't just their vast emptiness, but their apparent effects on the cosmic microwave background radiation that fills all of space. As light from the Big Bang's afterglow passes through these cosmic deserts, it seems to lose energy in ways that suggest the voids are actively draining the universe of its fundamental thermal background. This creates cold spots in the cosmic microwave background that appear as scars in the fabric of space itself. The mechanism by which supervoids can cool the cosmic background radiation remains one of the most puzzling phenomena in cosmology. Some theories suggest that these vast empty regions are expanding faster than the rest of space, creating a cosmic suction effect that literally pulls energy out of passing radiation. If this is true, then supervoids represent active processes rather than passive emptiness, cosmic engines that consume the very energy that fills the universe. But recent observations have revealed something even more disturbing about these cosmic deserts. They appear to be growing, expanding their boundaries, and consuming the matter at their edges, like three-dimensional black holes that operate according to unknown principles. Galaxies at the boundaries of supervoids seem to be gradually disappearing, their matter and energy vanishing into the expanding emptiness as if reality itself were being erased. The expansion of supervoids challenges our understanding of cosmic evolution on the largest scales. If these regions of emptiness are actively growing and consuming the matter around them, then the universe may be in the process of hollowing itself out, creating an increasingly empty cosmos where organized matter becomes ever more isolated, in shrinking islands surrounded by expanding seas of nothingness. The psychological impact of supervoids extends beyond their physical properties into the realm of existential horror. These regions represent spaces where the normal density of matter and energy that makes existence possible simply ceases to exist. To travel through a supervoid would be to journey through a cosmic wasteland where the very substrate of reality becomes so diluted that cause and effect might operate according to different rules than those that govern our local region of space. Some supervoids contain mysterious structures that astronomers call void galaxies, isolated stellar systems that somehow formed and survived in regions where matter density should be insufficient to create organized structures. These cosmic orphans exist in conditions so alien that they challenge our understanding of how galaxies can form and maintain themselves. They represent forms of cosmic life that have learned to thrive in environments that should be utterly hostile to organized matter. The discovery of void galaxies has forced astronomers to confront the possibility that life and organization can emerge even in the most desolate regions of the universe. If matter can organize itself into complex structures, even in cosmic deserts, where the normal processes of gravitational attraction barely function, then the universe may be far more resilient and creative than our theories predict. But this resilience comes with its own form of horror. If supervoids can give birth to isolated galaxies that exist in cosmic exile, what other forms of organization might emerge in these empty regions? Could there be entire civilizations that evolved in cosmic voids, developing technologies and perspectives so alien that they would be incomprehensible to matter-based life forms like ourselves? The existence of void galaxies also raises disturbing questions about the ultimate fate of our own cosmic neighborhood. As the universe continues to expand and dark energy drives galaxies apart, our local group may eventually find itself isolated in a growing supervoid, surrounded by expanding emptiness that cuts us off from the rest of the cosmic community. In the far future, civilizations in void galaxies may represent the only form of organized intelligence left in a universe that has expanded itself into cosmic loneliness. These isolated communities would inherit a cosmos where most of space consists of empty voids, where the cosmic microwave background has cooled to near absolute zero, and where the only sources of energy and matter exist in scattered island universes separated by distances that light cannot cross within the remaining lifetime of the stars. The supervoids that surround us today may be previews of the universe's ultimate destiny, cosmic laboratories where we can study what happens when reality itself becomes so diluted that the normal rules of existence no longer apply. They represent regions where the universe has already begun its journey toward maximum entropy, toward a state where organized matter and energy become increasingly rare exceptions in an ocean of expanding emptiness. As we peer into these cosmic deserts and contemplate their implications for the future of existence itself, we're forced to confront, perhaps, the most profound terror the universe has to offer. Not the immediate threat of gamma-ray bursts or rogue black holes, but the slow, inexorable expansion of nothingness itself, consuming the very fabric of reality and leaving behind a cosmos where isolation and emptiness become the dominant features of existence. The horror isn't that the universe might end with a bang, but that it might fade into a whimper of cosmic loneliness, where consciousness itself becomes an increasingly rare and precious phenomenon scattered across vast distances, in a reality that has forgotten how to create new forms of organization and complexity. Yet even as we contemplate these cosmic voids and their implications for the universe's ultimate destiny, we must return our attention to threats that operate on more immediate timescales, dangers that could transform our cosmic neighborhood from a relatively stable stellar environment into a scene of unimaginable violence within our own lifetimes. Our own solar system, that familiar collection of worlds we've studied and mapped with such care, harbors secrets that would terrify anyone who truly understood their implications. Beyond the orbit of Neptune, in the cold darkness of the Kuiper Belt and the even more distant Oort cloud, there exists a vast reservoir of cosmic artillery that could end our story with little warning. The Oort cloud, that spherical shell of icy debris surrounding our solar system, at distances up to 100,000 times farther than Earth orbits the Sun, contains trillions of objects ranging in size from snowballs to mountains. These frozen remnants from the solar system's formation drift in the darkness, following orbits so distant and elongated that they barely feel the Sun's gravitational influence. Most of these icy wanderers remain safely in the outer darkness, taking millions of years to complete their vast orbits around our star. But occasionally, something disturbs their peaceful trajectories. A passing star, the gravitational influence of the galactic tide, or collisions between the objects themselves, can send these frozen bullets plunging toward the inner solar system at speeds that transform them into weapons of unprecedented destruction. When one of these visitors from the outer darkness begins its journey toward the Sun, it becomes what we call a long-period comet. These cosmic travelers can approach from any direction, their orbits so unpredictable that we often discover them only months before their closest approach to Earth. Unlike asteroids, which follow relatively predictable paths that we can calculate years in advance, long-period comets represent a form of cosmic roulette where the stakes are measured in billions of lives. The destructive potential of a large comet impact dwarfs anything in human experience. These objects can measure dozens of kilometers across and travel at velocities exceeding 70 kilometers per second when they reach the inner solar system. The kinetic energy of such an impact would release more explosive force than every nuclear weapon ever built, detonating simultaneously across the entire planet. But the immediate impact would be merely the beginning of a global catastrophe that would unfold over months and years. The debris thrown into the atmosphere would block sunlight for extended periods, triggering a nuclear winter that could last for decades. Photosynthesis would cease across most of the planet's surface. Food chains would collapse. Ocean temperatures would plummet. The delicate chemical balance that makes Earth habitable would be shattered in ways that might take millions of years to restore. What makes the comet threat particularly insidious is its stealth nature. These objects spend most of their time in the outer darkness, where no telescope can detect them. They announce their presence only when they begin to develop the glowing comas and tails that make them visible, often when they've already passed the point where deflection becomes impossible with current technology. Recent observations have revealed that some long-period comets follow trajectories that suggest they've been perturbed by gravitational influences we don't fully understand. Computer models of the Oort cloud predict certain patterns of comet arrival. But the actual comets we observe sometimes deviate from these predictions in ways that hint at unknown forces operating in the outer solar system. Some astronomers have proposed that a hypothetical ninth planet, perhaps 10 times more massive than Earth, might exist in the outer reaches of our solar system. This theoretical world, dubbed Planet 9, would explain some of the orbital anomalies observed in trans-Neptunian objects. But if such a planet exists, its gravitational influence would constantly perturb the Oort cloud, sending streams of comets toward the inner solar system in patterns we cannot predict. The search for Planet 9 has revealed something equally disturbing about our cosmic neighborhood. The outer solar system contains populations of objects with orbital characteristics so bizarre that they challenge our understanding of how planetary systems form and evolve. Some of these objects follow paths that seem to require gravitational influences from sources we cannot identify. These trans-Neptunian objects exhibit clustering in their orbital orientations that suggests they've been shepherded into their current configurations by gravitational forces operating over millions of years. But the source of these forces remains mysterious, hidden in the darkness beyond our current observational capabilities. The possibility that our solar system contains massive objects we haven't discovered carries implications that extend far beyond academic curiosity. If there are unknown planets lurking in the outer darkness, their gravitational effects could be constantly reshaping the trajectories of comets and asteroids in ways that make impact predictions impossible. We might be living in a solar system where the threat level fluctuates according to the orbital dynamics of hidden worlds we cannot see. Our current asteroid and comet monitoring systems assume a relatively stable gravitational environment. But if massive unknown objects exist in the outer solar system, this assumption could be dangerously incorrect. Recent discoveries have also revealed that our solar system's passage through the galaxy exposes us to external gravitational influences that can destabilize the Oort cloud over geological timescales. As we orbit the galactic center, we periodically pass through the galactic plane, where the concentration of stars and dark matter is higher than average. These passages, which occur roughly every 30 million years, correspond to periods of increased comet activity and elevated extinction rates in the fossil record. The gravitational influences of dark matter concentrations and nearby stars can send waves of disturbance through the Oort cloud, triggering comet storms that bombard the inner solar system for millions of years. The realization that our solar system's threat environment varies according to our galactic orbit adds a cosmic dimension to the dangers we face. We exist not just in a solar system filled with potential impactors, but in a galaxy where our position relative to other stars and concentrations of dark matter determines the frequency and intensity of cosmic bombardment we experience. But perhaps the most disturbing recent discovery involves the detection of interstellar objects passing through our solar system. In 2017, astronomers detected Oumuamua, an elongated object from another star system that had entered our cosmic neighborhood and was already departing by the time we noticed it. The properties of Oumuamua defied easy explanation. Its unusual shape, reflective properties, and trajectory suggested it might be an artificial object rather than a natural asteroid or comet. While most scientists concluded it was likely a natural interstellar visitor with unusual characteristics, its discovery opened unsettling possibilities about what else might be traveling through the space between stars. If our solar system is regularly visited by objects from other star systems, we exist in a much more dynamic and unpredictable cosmic environment than previously thought. These interstellar travelers could arrive from any direction at any time, carrying with them materials, compositions, and possibly even biological contamination from alien worlds. The detection capabilities that allowed us to spot Oumuamua only became available recently, suggesting that countless similar objects may have passed through our solar system throughout history without our knowledge. We might be living in a cosmic crossroads where visitors from distant stars regularly transit our neighborhood, invisible to our detection systems until they're already departing. Some of these interstellar visitors might not be natural objects at all, but artifacts from alien civilizations, probes sent to study other star systems, or even derelict spacecraft from technological species that arose and fell long before Earth developed complex life. The possibility that our solar system is regularly visited by alien technology, whether active or inactive, adds a science fiction element to our cosmic threat assessment. But even natural interstellar objects represent potential dangers we're only beginning to understand. These visitors carry materials forged in alien star systems, composed of elements and isotopes that formed under conditions very different from those that created our solar system. Their impact with Earth could introduce exotic matter into our biosphere with unpredictable consequences. The chemistry of interstellar space differs dramatically from the relatively protected environment of our solar system. Objects that have traveled for millions of years through the interstellar medium have been bombarded by cosmic radiation, exposed to extreme temperatures, and possibly altered by encounters with exotic forms of matter we can only theorize about. When these alien visitors enter our solar system, they bring with them samples of cosmic environments so different from our own that they might as well be arriving from parallel universes. Their compositions could include materials that don't exist naturally anywhere in our solar system, compounds formed under pressures and temperatures that our models cannot reproduce. The biological implications are equally unsettling. If life exists elsewhere in the galaxy, interstellar objects could serve as vectors for biological contamination on a cosmic scale. Microorganisms capable of surviving the harsh conditions of interstellar space could hitchhike aboard these visitors, introducing alien biochemistry into our terrestrial environment. The possibility of reverse contamination is equally disturbing. Objects that graze our atmosphere or impact our planet could carry samples of Earth's biosphere back into interstellar space, spreading terrestrial life forms to other star systems where they might compete with or replace indigenous life forms. As our detection capabilities improve and we discover more interstellar visitors, we're forced to confront the reality that our solar system exists in a galaxy where matter, energy, and possibly even life regularly travels between star systems. We are not isolated on our cosmic island, but part of a galactic ecosystem where the boundaries between stellar neighborhoods are more porous than we ever imagined. The increasing frequency of these discoveries suggests that interstellar objects may be far more common than we previously thought. Our solar system might be constantly traversed by visitors from distant stars, most too small or moving too quickly for our current instruments to detect. We exist in a cosmic environment where the alien is commonplace, where materials and possibly even life forms from other worlds regularly pass through our neighborhood. Yet as we catalogue these cosmic threats and contemplate their implications for our planet's safety, we must acknowledge that the universe's capacity for creating dangerous phenomena extends far beyond anything we've yet discovered. The cosmos operates according to principles so vast and complex that our current understanding likely represents only the smallest fraction of the forces and phenomena that shape reality on cosmic scales. Every new discovery, every improvement in our observational capabilities reveals additional layers of cosmic complexity that challenge our assumptions about the nature of existence itself. We live in a universe that consistently exceeds our ability to predict or comprehend its behavior, where the impossible becomes routine and the routine reveals hidden depths of mystery and danger. The terror of cosmic existence isn't just that specific threats like gamma-ray bursts or asteroid impacts might end our civilization. It's that we exist in a reality so fundamentally strange and unpredictable that we cannot even catalogue all the ways it might surprise us with new forms of beauty, wonder, and annihilation. As you drift towards sleep tonight, carried by the rhythm of your own breathing, remember that you rest on a small world orbiting an ordinary star in an unremarkable galaxy, yet surrounded by phenomena so extraordinary that they challenge the very concepts we use to understand existence. The gentle darkness that embraces you as consciousness fades is filled with invisible forces, hidden structures, and cosmic processes that operate on scales ranging from the quantum to the galactic. Every photon of starlight that reaches your eyes has traveled across vast distances, carrying information about cosmic violence and beauty that plays out across billions of years. The atoms in your body were forged in stellar cores and scattered by supernova explosions, making you a temporary arrangement of cosmic matter temporarily organized into the remarkable phenomenon we call consciousness. You are part of this cosmic story, not separate from it, a brief flowering of complexity in a universe that seems determined to explore every possible form of existence, from the most beautiful to the most terrifying. In understanding why the universe contains such extraordinary capacity for both creation and destruction, we glimpse something profound about the nature of reality itself. The cosmos doesn't create beauty and horror as separate phenomena, but as different aspects of the same fundamental processes that govern how matter and energy organize themselves across space and time. The same forces that create galaxies and stars also create black holes and gamma-ray bursts. The same physics that allows consciousness to emerge from matter also ensures that all organized structures eventually succumb to entropy. Tonight, as you prepare to surrender consciousness to the mysteries of sleep, you can rest in the knowledge that you are part of something magnificent and terrible, beautiful and dangerous, comprehensible and utterly mysterious. The universe cradles you in its vast embrace. The same cosmic forces that threaten destruction on unimaginable scales, also nurturing the delicate conditions that allow minds like yours to exist and wonder about their place in the infinite darkness. Sweet dreams, fellow traveler in this cosmic odyssey, knowing that you are both infinitely small and infinitely precious, a conscious witness to the universe's ongoing exploration of its own magnificent and terrifying possibilities. The darkness between heartbeats holds secrets that would shatter your peace forever. As you lie there listening to the steady rhythm of your pulse, you might assume that the space around you is simply empty air, filled with nothing more threatening than dust motes dancing in whatever dim light filters through your windows. But the truth is far more unsettling than your peaceful moment suggests. Right now, streaming through your bedroom at nearly the speed of light, are particles so energetic they could rewrite the very genetic code that makes you who you are. These cosmic rays, born in the death throes of distant stars and accelerated by magnetic fields that span entire galactic arms, penetrate every surface on Earth as if solid matter were nothing more than a gentle suggestion. Your body is being bombarded by thousands of these invisible bullets every second. Most pass through you harmlessly, but occasionally, one of these cosmic messengers carries enough energy to shatter the delicate molecular machinery inside your cells. Each impact represents a tiny lottery ticket in a game where the prize is cancer, genetic mutation, or cellular death. What makes cosmic ray bombardment particularly chilling is its relentless nature. There is no shelter from this assault, no bunker deep enough to provide complete protection. Even a mile underground, these particles find you, drilling through rock and steel as if they were made of mist. The deeper you go, the more the Earth itself becomes radioactive, transformed by cosmic ray impacts into a source of secondary radiation that can be more dangerous than the original cosmic bullets. Airline pilots and flight attendants receive higher doses of cosmic radiation than most nuclear power plant workers. At cruising altitude, the thin atmosphere provides little protection from the cosmic particle shower that rains down continuously from space. Frequent flyers accumulate radiation exposure equivalent to multiple medical X-rays with each transcontinental journey, their bodies serving as unwilling detectors for cosmic violence that began billions of years ago in galaxies whose names we'll never know. But cosmic rays represent just one form of invisible threat that permeates our seemingly safe environment. The very atoms that make up your body are engaged in a constant process of radioactive decay, transforming themselves into different elements while releasing particles that damage the molecular structures around them. Every breath you take contains radioactive carbon-14. Every bone in your body harbors radioactive potassium-40. Every cell carries within it the seeds of its own destruction through processes that operate according to quantum mechanical probability rather than any schedule we can predict. The potassium in your muscles, essential for nerve function and muscle contraction, occasionally undergoes spontaneous nuclear decay, releasing energetic particles that can damage nearby DNA. Your skeleton, built from calcium and phosphorus extracted from your diet, also contains traces of radium that slowly transforms into radon gas, making your bones a source of internal radiation exposure that continues throughout your lifetime. Even the water you drink carries dissolved uranium, thorium, and radon, making every glass of liquid a dilute radioactive cocktail. The concrete in your home's foundation contains naturally occurring radioactive elements that slowly emit gamma rays, while the smoke detectors protecting you from fire use radioactive americium to function. You exist in a world where radioactive decay is so commonplace that it's woven into the basic infrastructure of modern civilization. But natural radioactivity pales in comparison to the cosmic accidents that have already marked our planet with invisible scars. Scattered across Earth's surface are impact sites where cosmic visitors delivered payloads of exotic radioactive isotopes that don't occur naturally in our solar system. These alien elements, forged in stellar cores far from our Sun, continue to decay according to half-lives that stretch across millions of years, creating persistent radioactive hotspots that serve as monuments to cosmic collisions. The Sudbury Basin in Ontario, Canada, one of Earth's oldest and largest impact structures, still shows elevated levels of iridium, platinum, and other rare metals delivered by the asteroid that created this scar nearly 2 billion years ago. These alien elements continue to influence the local geochemistry, creating conditions that affect everything from groundwater composition to the health of organisms living in the region. Similar radioactive signatures exist at impact sites around the world, each one a crime scene where cosmic violence left behind evidence that persists across geological time. The Chicxulub crater in Mexico, created by the asteroid impact that ended the age of dinosaurs, still harbors concentrations of shocked minerals and exotic isotopes that tell the story of that catastrophic day 66 million years ago. But impact-delivered radioactivity represents just one way that cosmic events can contaminate our planet with invisible dangers. Throughout Earth's history, nearby supernova explosions have showered our world with radioactive isotopes that settle into the geological record like cosmic fingerprints. These stellar explosions, occurring within a few hundred light-years of our solar system, can deliver enough radioactive material to affect global climate patterns and trigger mass extinction events. Scientists have identified layers in ocean sediments that contain elevated levels of iron-60, a radioactive isotope that can only be produced in supernova explosions. These cosmic signatures appear in the geological record at times that correlate with climate changes and species extinctions, suggesting that stellar death throes have repeatedly influenced the course of evolution on our planet. The most recent nearby supernova event, which occurred approximately 2 million years ago, deposited enough iron-60 in Earth's environment to remain detectable in deep ocean sediments. This stellar explosion may have contributed to climate cooling that affected human ancestors in Africa, potentially influencing the evolutionary pressures that shaped our species' development. But supernovae deliver more than just radioactive isotopes. They also accelerate cosmic rays to energies so extreme that they can trigger cascades of secondary particles when they strike Earth's atmosphere. These air showers create brief moments when the radiation levels at ground level spike to dangerous levels, particularly at high altitudes where the atmosphere provides less shielding. Mountain climbers and high-altitude researchers occasionally encounter these cosmic ray air showers, experiencing sudden spikes in radiation that can deliver doses equivalent to medical X-rays in a matter of seconds. The unpredictable nature of these events makes high-altitude activities a form of cosmic roulette, where the stakes are measured in cellular damage and increased cancer risk. Pilots flying polar routes face additional radiation hazards from solar particle events, those massive ejections of charged particles from our Sun's surface that can arrive at Earth with little warning. During major solar storms, radiation levels at airline cruising altitudes can become so elevated that flights are diverted to lower altitudes or different routes entirely to protect passengers and crew from potentially lethal exposure. The most severe solar particle events can make the upper atmosphere temporarily uninhabitable for human beings. Astronauts aboard the International Space Station must retreat to shielded compartments during major solar storms, while satellite operators shut down sensitive equipment to prevent radiation damage. These solar tantrums serve as reminders that even our relatively well-behaved parent star can become a source of deadly radiation without warning. But radiation represents just one face of the invisible threats that surround us. Hidden in the quantum foam of empty space are virtual particles that pop in and out of existence, according to principles so bizarre they seem borrowed from supernatural horror rather than physics. These quantum fluctuations create an underlying instability in the vacuum itself, making even the emptiest regions of space seething with potential energy that could, under the right circumstances, transform into real particles with devastating consequences. The Casimir effect demonstrates that empty space isn't truly empty, but filled with virtual photons that exert measurable forces on nearby objects. These quantum vacuum fluctuations represent a form of cosmic restlessness that permeates all of existence, creating conditions where the boundary between something and nothing becomes blurred beyond recognition. Some theoretical physicists have proposed that quantum vacuum fluctuations could spontaneously create bubbles of space-time with different physical properties than our own. These false vacuum decay events would expand at the speed of light, transforming matter according to new physical laws and essentially erasing our current form of reality from existence. The universe itself might be metastable, existing in a state that could collapse into a lower energy configuration at any moment. If such a vacuum decay event were triggered anywhere in the universe, we would have no warning of its approach. The bubble of altered space-time would arrive at our location traveling at light speed, preceded by no signal that could alert us to the coming transformation. Everything we've ever known would be instantly converted into forms of matter and energy, governed by alien physical constants. The probability of spontaneous vacuum decay is thought to be extraordinarily small, but the consequences would be so absolute that even tiny probabilities become sources of existential anxiety for anyone who truly understands the implications. We exist in a universe where the very structure of space-time might be unstable, where quantum mechanics allows for possibilities so extreme they challenge our basic assumptions about the permanence of physical reality. Recent discoveries in particle physics have revealed additional quantum phenomena that operate on macroscopic scales in ways that defy classical understanding. Quantum entanglement, that spooky action at a distance that troubled Einstein, has been demonstrated between objects large enough to be visible to the naked eye. The boundary between the quantum world and the classical world appears to be far more porous than previously thought. If quantum effects can influence macroscopic objects, then the weird uncertainties that govern subatomic particles might also apply to larger structures. The possibility that entire planets or star systems could exist in quantum superposition states, simultaneously occupying multiple configurations until observed, represents a form of cosmic horror that transcends physical threats and enters the realm of metaphysical uncertainty. And so we reach the end of our journey through the cosmic catalogue of terrors, having peered behind the gentle facade of twinkling stars to discover the universe's true nature, as a realm of unimaginable violence and beauty intertwined. From rogue black holes stalking through the galactic darkness, to quantum uncertainties that challenge the very foundations of reality, we've explored phenomena so extraordinary they stretch the boundaries of human comprehension. Tonight, when you look up at the night sky, you'll never see it the same way again. Those distant points of light aren't just peaceful celestial decorations, but markers of cosmic battlefields, where matter and energy wage wars across scales, ranging from the quantum to the galactic. You now know that the darkness between stars teems with invisible predators, stellar zombies, and forces so alien they operate according to physics we're only beginning to glimpse. Yet perhaps the most remarkable discovery of all is that we exist at all in such a hostile cosmos. Against odds so staggering they defy calculation, consciousness has emerged from stellar death and cosmic violence to contemplate its own impossible existence. We are the universe's way of experiencing wonder at its own magnificent and terrible creativity. So rest well tonight, fellow cosmic wanderer, knowing that you are part of the most extraordinary story ever told. The same forces that create gamma-ray bursts and magnetars also nurture the delicate conditions that allow minds like yours to exist and marvel at the infinite mystery surrounding us. In a universe filled with such beautiful horrors, the greatest miracle may be that there are beings capable of appreciating both the terror and the wonder of it all.